Okay, so this video we're going to talk about accuracy and precision, both really important things when you're talking about scientific measurement. So accuracy is how close is a measurement to the actual value. So a pretty common example is the dartboard thing. You have a dartboard here. Forgive me for my drawing. Alright, the red is the bullseye in the middle. Accuracy would be if you hit, right here, right near the bullseye. All these are accurate dart spots. Inaccurate would be over here, or way out here, or wherever else. Okay? So, accurate, how close you are to the actual value of the actual measurement. Inaccurate is far away. Another way you could put it is, if you measure let's say a wood block as 2.76 grams, but in reality the actual value of the block is 2.89 grams, you can calculate how accurate you were just by finding the difference. You were off by 0.13 grams here. That would be your error, which we'll talk about in a little bit. So that's accuracy. So we can contrast accuracy with precision, which is just getting the same result over and over. So back to the dartboard here. Alright, so accuracy is when we said hitting the bullseye right in the middle, right on the red spot. Precise would be every dart is going in the same spot. Now it's not necessarily accurate. It could be. But right now we just have a precise result. We're doing the same thing over and over. If we were to hit right here, over and over, that would be accurate and precise, because one, we are hitting the bullseye like we wanted, and two, we're getting the same thing over and over. Back to the wood block example, where we said the actual value was 2.89 grams, the actual mass of the block. Let's say we measured it once, and let's say we got 7.6 grams, and then we measured it again. Let's say this is trial 2, and we got 7.7 grams. We measured it a third time, and we got 7.6 grams again. Alright? These measurements are obviously not accurate. We're way off, and whatever we were doing to measure was not very good. However, they are precise because we are getting the same result over and over. That's the key with precision. Now, a lot of times you'll see both. Both is what you want. Hitting the bullseye over and over. That's accurate and precise. But there is a difference. You can be accurate without being precise, and you can be precise without being accurate. So you might be wondering why we're talking about accuracy and precision, because this is science, not darts, right? Well, when you're making measurements, both accuracy and precision both play a huge role. Let's look at an example here. So let's say we have a ruler that measures in inches, and it's marked 1, 2, 3, 4, so on. And we want to measure the length of this blue line here. Well, the rule that you use is you take all of your certain digits, alright, you take everything that you know for certain because it's marked first, okay? So if we look at this, if you look at our ruler here, we only have, 1, 2, 3, 4, so on. So we know that we can tell it's between 2 and 3 here, so we know it's 2 point something. So we can write that for certain. We know it's 2 point something. That's certain because it's marked. However, we don't know anything else for certain because there are no markings in between to tell us 2.2, 2.4, 2.7, So, we will have to estimate. The rule is you estimate one uncertain digit. So you write your certain digit first, and then you estimate one uncertain digit. Don't estimate 2, don't estimate 3, don't estimate 17, just one. So looking at our ruler here, I'd probably say 2.5. Okay, I would probably say 2.5. Maybe it's 2.6. It's hard to tell, but really it's just an estimation, so we'll do the best we can. Can't say 2.57. There's no need to be that precise, so you can't do that. Let's get rid of that. So, 2.5. There you go. So you take the certain digit and you estimate that one uncertain digit. Let's try another example. So here we've got a graduated cylinder, and we're measuring the level of some liquid in the cylinder. Alright, so first step, let's write down our certain digit. So if we look at the water level, it's clearly between, 1 1 over here, and 2 up here. So we know for certain, we can say for certain that it's 1 point something. We know that much for certain. So the next step is, do we know anything else for certain? Well, if we look at our measurement, we've got tenth markings up and down the side. Horribly drawn tenth markings. So let's see, 1.1, 1.2, 1.3. Looks like it's between 1.2 and 1.3. That's what the markings are telling us. So we can say for certain 1.2 something. Now there are no more markings beyond that. So anything else after this is estimation. And I just told you guys, the rule is you estimate one uncertain digit. So if we look at our marking right here, I would say it's probably closer to 1.3. Looks pretty close. So I'm going to go with 1.28. Probably measuring milliliters here. 1.28 milliliters. So the 1 and the 2 are certain digits because they're marked. We know 1.2 for certain. The 0.8 is an estimate, and you always want to have that one estimated digit. We call that the uncertain digit. So just to kind of tie things together, the reason that we limit the number of digits you write is because the more digits you write, the more precise that you're being. So we have two measurements here. This one at the top, 2.4705 grams. That's a really precise measurement. Whatever we used to measure this, I'm assuming electronic balance, was really, really precise. So we were able to use this many decimal places. The second measurement is the same thing, right? 2.5. It's the same measurement as this. The only difference is we had to round because whatever we were measuring with was not as precise. So for the rules about how to round, check out the next video called Significant Figures.